State machine model. A state machine model is a design pattern commonly used in embedded systems to describe how a system should behave based on different inputs and conditions. It is a mathematical model that consists of a set of states, events, and transitions. In an embedded system, the state machine model can be implemented using software or hardware. The basic idea is to define the different states that the system can be in and the events that can trigger a transition from one state to another. The transitions are typically controlled by some decision logic that takes into account the current state and the input or condition that caused the transition. For example, let's say we have a simple embedded system that controls a traffic light. The system can have three states: green, yellow, and red. The events that can trigger a transition are the passage of time and the presence of a car at the intersection. When the system is in the green state, the traffic light is green, and cars can pass through the intersection. After a certain amount of time, the system transitions to the yellow state, where the traffic light turns yellow to signal that the light is about to change. Another transition occurs after a certain amount of time, moving the system to the red state, where the traffic light turns red, and cars are stopped. If a car is detected at the intersection while the traffic light is green or yellow, the system transitions immediately to the red state to stop the cars and prevent accidents. Overall, the state machine model provides a clear and structured way to design embedded systems, allowing developers to define all possible states and transitions and ensure the system behaves predictably and reliably in different conditions. Sequential program model. In the sequential program model, a program is written as a series of instructions that are executed in a specific order, one after the other. This means that each instruction is executed only after the previous instruction has completed. The execution of the program is therefore sequential, with each instruction executed in the order specified by the program. In embedded systems, the sequential program model is commonly used because it allows for precise control over the timing and execution of operations. This is particularly important in real-time systems, where timing is critical. To illustrate the sequential program model in embedded systems, let's consider an example of a simple embedded system that controls a traffic light at an intersection. The program for this system might be written in a sequential manner as follows. Step 1. Check the current state of the traffic light. Step 2. Determine the next state of the traffic light based on the current state and the traffic pattern. Step 3. Update the traffic light to the new state. Step 4. Wait for a specified period of time. Step 5. Go back to step 1 and repeat. In this example, each step of the program is executed sequentially, with each step depending on the completion of the previous step. The program first checks the current state of the traffic light, then determines the next state based on the current state and the traffic pattern. The program then updates the traffic light to the new state, waits for a specified period of time, and then repeats the process by going back to step 1. Overall, the sequential program model in embedded systems is a straightforward and effective way to control the execution of operations in a precise and predictable manner.